Okay, algebra. So we got example 2 here on square roots in the denominator. So I've got 6 over the square root of 5 minus the square root of 2. Your first instinct might want to be to do square root of 5 minus square root of 2 is root 3. But you can't do that. If you remember, we learned you can't subtract square roots if they're not the same number under the root. So we got to somehow figure out a way to get rid of the square roots on the bottom. What we're actually going to do is kind of a difference of squares in reverse. So what I'm going to do is I'm going to multiply by root 5 plus root 2. And the reason being is you'll see in the end, it'll end up canceling out all the middle terms, and we'll end up with two perfect squares subtracting each other, and we'll get a whole number, which is what we want on the bottom. If we get a whole number on the bottom, we no longer have a square root on the bottom, and it can be simplified. Now, if I'm going to multiply by root 5 plus root 2, I got to multiply by root 5 plus root 2 on top, because I got to do the same thing on top and the bottom. So, because this was root 5 minus root 2, I chose root 5 plus root 2. If this had been a plus here, I would have chose a minus there. You always do the opposite sign. So now, I'm going to distribute up here. I'm going to act like these are in parentheses. 6 times root 5 is 6 root 5. 6 times root 2 is 6 root 2. So, then on the bottom, I'm going to imagine these are both in parentheses, and I'm going to do the FOIL method. We learned this in the last lesson. So I do my first terms, root 5 times root 5 is the square root of 25. Oop, that's a 25. Then I do my outer, root 5 times root 2 is root 10. I do my inner, negative root 2 times root 5 would be negative root 10. And then my last, negative root 2 times positive root 2 would be negative root 4. And if you notice, our two middle terms right here and right here are going to cancel out. And that's the point. Because we chose this difference of squares method, our two middle terms cancel out. So all of a sudden on top, I got 6 root 5 plus 6 root 2. On the bottom, I've got square root of 25, which is just 5. Root 10 minus root 10 cancels out. And then the square root of 4, which is 2. So on the bottom, you can see I just got 5 minus 2. So if I were to bring this up here, I've now got 6 root 5 plus 6 root 2. All of that over. 5 minus 2 is just 3. And now you see no square root on the bottom. I'm good. I don't have a root on the bottom, but double check, make sure now that can be simplified. I look at my root, square root of 5. No perfect square goes into 5. 2, no perfect square goes into 2. But both of these have a 6 in front, and this is a 3 on the bottom. Both of those can be, I can do 6 divided by 3. I can simplify both of those. 6 divided by 3 is 2, so I get 2 root 5. 6 divided by 3 is also 2, plus 2 root 2. And that is my answer. All right, so that's example 2. I've got one more coming, so check that out.